All right, so let's look at our first problem. You are working for a ferry company and they are designing their ferries, and they can carry lifeboats and life vests. The chances of surviving in a lifeboat are better, but the lifeboats take up more space, so they're not going to equip enough lifeboats for all the passengers. They will make up the rest with life vests. You have to decide how many of each to put. Let's look at the specifics. So, the details. The company says each vest will hold one person and requires 0.05 meters cubed of space to store. Each boat can hold 20 people and requires 2.1 meters cubed of space to store. They must have a capacity for 1,000 people in one or the other. That's how many they want to carry, including staff and passengers. And the total space that they want to use for the equipment is 85 meters cubed. Any more than that, they're limiting space for passengers. How many of each should we install? So let's first do a sanity check, make sure that the problem is reasonable. So first thing we're going to check is what happens if we do all lifeboats. If we do all lifeboats, we have 1,000 people. Each lifeboat holds 20, and then takes up 2.1 meters cubed of space. We get 105 meters cubed. Okay, so that's too big. We cannot solve the problem by using all lifeboats. We do have an issue with that. Okay, what if we do all life vests? Is that even going to fit? Let's just do a quick check. So 1,000 people need 1,000 life vests, 0.05 meters cubed each. That is 50 meters cubed. So that will fit. So that means we want to go somewhere in between. We could save more people than putting only life vests, but we can't have all lifeboats. So let there be X lifeboats and Y life vests. And then let's see what happens. So 20 people per lifeboat, one person per life vest. That should be at least 1,000. We might not get exactly 1,000. Let's just make it exactly 1,000 for now. We'll solve the equation, see what happens. Then 2.1 meters cubed per life boat, 0.05 meters cubed per life vest, total of 85 meters cubed. And again, that should be less than or equal to 85, but we'll solve it for equals. We probably want to get pretty close to these numbers for the optimal solution. Solve the system of equations any way you want. By computer, matrix would be the best. By hand, elimination is probably the easiest. So we're going to multiply the second equation by 20. We get 42x plus 20 times 0.05 is 1. Y. 20 times 185 is 1,700. And then if we do equation 3 minus equation 1, the y's will cancel. So 22x equals 700. X is 700 over 22. I'm in the habit of reducing the fraction, but we don't have to do that. We're in the real world. So we have 31.81 repeating lifeboats. We'll adjust that number in a minute, but the accurate number is that. And then we look at equation 1. We get y is 1,000 minus 20 times this number. Go to the decimal right away here. 363.63 repeating life vests. Okay, we're not going to go back and tell the company to do fractional lifeboats and life vests. This is discrete mathematical modeling. So we're going to say we'll round down to 31 lifeboats so that we don't go over their 85 meter cube limit. Okay, so we have to solve for y again. Y is now 1,000 minus 20 times 31 is 380 life vests. So you go to the company and you say, you should put 31 lifeboats and 380 life vests. And the company says, hold on, no, we don't want to do that. We want an even number of lifeboats. Why? Because lifeboats are always placed opposite each other on sides of the aisle. If we put an odd number, that's just wasting space. You say, okay, fine, you didn't tell us that, but this is the back and forth part of the real life modeling. Okay, so let's offer some solutions. If you put 30 lifeboats, because that is now the biggest even number that will fit, do this again, 1,000 minus 20 times 30 is 400 life vests. That's one solution. Or let's look at this 31.81 repeating number. That's awfully close to 32. 30 seems like a little bit of a waste. So, okay, they didn't say this, but let's give them an alternate solution. 32 lifeboats. Let's just see how bad this is. 32 lifeboats. This would give, that's 32, is 360 life vests. Okay, we have to figure out how bad that is. How much space does that take? It's going to go a little bit over. But then the total volume is 32 times 2.1 plus 360 times 0.05. That works out to 85.2 meters cubed. That's really, really close to 85 meters cubed. Okay, so you go and present this to the company. You say, well, you could do 30 lifeboats and 400 life vests and stay under capacity. Or, if you're willing to sacrifice another 0.2 meters cubed, we could do 32 lifeboats, 360 life vests, save more people in case of emergency. And they say, yeah, that's great. 85 was an estimate. We'll do 85.2 meters cubed. Your problem is solved.